Welcome to another episode of learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems that have appeared in the CSIR National Eligibility Test held on February 28, 2025. Today, we will discuss the solution of a problem from the section Real Analysis, and this problem is related to the truthfulness of the four statements given in the question. This question is placed in part C, which is a multiple select question. There can be more than one answer, and the question carries 4.75 marks. The question ID is 704141. This question is suitable for all these examinations. Right. The given question is, which of the following statements are true? So we are given four statements and we have to discuss the truthfulness of these statements. We are given four options. Option 1, let x, y be real numbers with x less than y. Then there exists R belongs to Q. There exists a rational number R such that x less than 2 power 2024 multiplied by R whole by E is less than y. Option 2, let n greater than or equal to 2 be a sequence of positive real numbers. If there exists a positive real number L such that limit superior an by log n is equal to L, then the limit superior of an is finite. Option 3, the set of all finite subsets of Q is countably infinite. Option 4, the set of continuous functions from R to the set consisting of two elements 0, 1 is finite. Right. Let's now discuss the solution of the problem in detail. We consider option 1. Let x, y be real numbers with x less than y. Then there exists a rational number R such that x less than 2 power 2024 multiplied by R by E is less than y. Right. This is true. We will show you how this is true. We have x, y be any two real numbers such that x less than y. Multiply both sides by E. E is a positive number. Ex less than Ey. The inequality is not get disturbed because E is a positive real number. And multiply both sides by 1 by 2000 2 power 2024. Then we will get Ex by 2 power 2024 less than Ey by 2 power 2024. Right. Now this is a real number. This is also another real number. They are distinct real numbers are there. We recall the property of rational numbers. Their rational numbers are dense. That means to say between any two distinct real numbers, there exists infinitely many rational numbers. Clearly, these are distinct real numbers. Now there exists a rational number R such that Ex by 2 power 2024 less than or less than e power ey, not e power, ey by 2 power 2024. Ex by 2 power 2024 less than or less than ey by 2 power 2024. This happens. Why? Because between any two distinct real numbers, there are infinitely many rational numbers. That is the denseness of the rational numbers. Right. Now what I will do, x less than y, this is what we have, then multiply throughout by 2 power 2024 by e, throughout. Then you will get x less than 2 power 2024 multiplied by r by e less than y. Thus, we got the option 1. Thus, option 1 is true. Right. We continue. Yeah. Option 2 is here. Let a and n greater than or equal to 2 be a sequence of positive real numbers. If there exists a positive real number L such that limit superior a n by log n is equal to L, then limit superior of a n must be finite. Is it so? So consider, this is a counterexample. Consider the sequence a n greater than or equal to 2 where a n is log n itself. Then limit n tends to infinity of a n by log n is limit n tends to infinity of log n by log n is 1. So thus we have a positive real number L is equal to 1 such that limit superior can be L. Because the limit exists, limit superior certainly exists and it is equal. So now there exists a L is equal to 1, a positive real number such that limit superior of a n by L log n is L, that is equal to 1. But the sequence a n where a n is log n is a divergent and diverges to plus infinity. They are all positive real numbers and diverges to plus infinity. When it diverges to plus infinity, what will be its limit superior? Limit superior cannot be a finite quantity. Therefore, limit superior of a n cannot be finite. Thus, option 2 is not true. Agreed. Good one. Let's go to the option 3. The set of all finite subsets of Q is countably infinite. This directly follows from a result. This follows directly from the following result. The result is about any countable set. The result says the set of all finite subsets of any countable set is countably infinite. The set of all finite subsets of any countable set is countably infinite. So you take Q is a countable set. Therefore, the set of all finite subsets of Q is countably infinite, and the result follows. Since Q is countable, the statement 3 is true. Thus, option 3 is true. Agreed. We move to the next option. Option 4. The set of continuous functions from R to the set consisting of two elements 0, 1 is infinite. So how many continuous functions will be there from R to this set consisting of 0 and 1? Continuous functions. Let f from R to the two element set 0, 1 be any continuous function. Then f of R, that is the image of f, the image of R under f must be connected, where it should be a connected subset of the two element set 0, 1. Right. Why this happens? Because the continuous image of a connected space is also connected. F is continuous, R is connected, F of R is also connected. And connected subset of the two element set 0, 1. But it is known that the connected subsets of the 2-point discrete space 0, 1 are singleton sets, that is singleton 0 and singleton 1. So that means how many continuous functions will be there? There will be only two continuous functions. F of R must be singleton 0 or singleton 1. Thus, the only continuous functions from R to this two element set 0, 1 are two constant functions. What are they? F of x is equal to 0 for all x belongs to R, and f of x is equal to 1 for all x belongs to R. So there are only two continuous functions from R to the set 0, 1. But the option says the set of continuous functions from R to the set 2-point set 0, 1 is infinite. It's not infinite, it is finite, and more precisely, there will be only two continuous functions. Therefore, option 4 is not true. Right. So, summarizing all the options, the answer to this question are options 1 and 3. That is the detailed discussion of the solution of this problem. In this problem, the examiner has given 4 statements, and he has asked us to find how many of them are true. That is the truthfulness of the statements that we have to discuss. Right. And it is actually the statements given are some of the properties of certain statements. Right. In the case of 1, option 1, it is a property of real numbers. In the option 2, it is a property of sequences. And the option 3 is a property of countable sets. And option 4, it talks about the property of continuous functions from R to the 2-point space, that is 0, 1. So these are 4 different items what he has given, and given as a question to find out the truthfulness of the statements. Right. I am sure that you understood the solution of this problem. Thank you for watching this video now. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Yes, I am sure we are going to meet you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.